Hello, brilliant student, welcome. We are solving question 40 from the WAEC 2026 chemistry exam. Our goal is to find the exact value of X in this redox half reaction. Notice how X appears in two places on your screen, right here next to the water molecule and over here determining the number of electrons. Think of this chemical equation exactly like a physical scale. Every single atom we have on the left side, among our reactants, must perfectly balance out the atoms on the right side, our products. We always verify our atoms one by one, and we start with the easiest element. Let us look at carbon. On the left side, the oxalate ion contains 2 carbon atoms. On the right side, the 2 carbonate ions also provide exactly 2 carbon atoms. Since carbon is already perfectly balanced, it does not reveal the value of our unknown. We must examine the remaining elements to solve for X. Let us track the oxygen atoms. Look at the reactant side. We start with 4 oxygen atoms provided by the oxalate ion. Then we add the oxygen from the water molecule. Because there is an X in front of H₂O, that contributes X more oxygen atoms. Now look at the product side, focusing on the carbonate ion. We calculate the total oxygen by multiplying the main coefficient, 2, by the atomic subscript, 3. 2 times 3 gives us exactly 6 oxygen atoms on the right. We can now set up a simple algebraic scale. 4 plus X equals 6. Subtract 4 from both sides, and we calculate that X equals 2. We insert that 2 into our water molecule, making it 2H₂O. But pause right here. A very common exam mistake is to look at the 4H plus on the product side and immediately guess that X must be 4 to match it. That 4H plus simply represents 4 single hydrogen ions. If we check our 2 water molecules on the left, we multiply the coefficient 2 by the hydrogen subscript 2. That yields exactly 4 hydrogen atoms, perfectly matching our right side. Systematically solving for oxygen provided the correct coefficient, and checking the hydrogen confirmed the math. This prevents us from falling for a deceptive visual trap. Electrical charges provide an independent way to verify our answer. Water is neutral, so the entire left side has a total charge of -2, coming directly from the oxalate ion. Over on the right side, we have 3 separate components contributing to the total charge. I want you to try this yourself. Pause the video and calculate the total charge of those products on the right side. Here is the correct step. We multiply the large coefficients by the polyatomic ionic charges. 2 times -2 gives -4. 4 times +1 gives +4. Those two values cancel each other out entirely to equal 0. The only charge left on the right side comes from our unknown electrons. X times -1 is -X. Setting the left charge equal to the right charge, we get -2 equals -X. This means X equals 2. Both the physical atom count and the invisible electrical charges align on the exact same number. Our answer is absolutely correct. Let us lock in these rules with a quick quiz. In 2H₂O, how many total hydrogen atoms are present? If you chose option C, you are correct. 1 water molecule has 2 hydrogen atoms. Multiplying that by the coefficient 2 gives us 4. Here is your second quiz. What is the total electrical charge of 2 carbonate ions, 2CO3₂-? The answer is B. You take the coefficient of 2 and multiply it by the -2 ionic charge, resulting in -4. Back to our WAEC question. The balanced equation requires a 2 for water and 2 electrons. The correct option is D. On exam day, use this shortcut. When X is beside water, scan oxygen first. 4 plus X equals 6, so X equals 2. Mastering these verification methods guarantees your exam confidence. For more step-by-step explanations to help you conquer WAEC, JAMB, and GCE, rush over to QandAHelp.com. Subscribe to this channel and let us continue studying together.